Hello again, everybody. Yesterday we looked at monomials divided by monomials and polynomials divided by monomials. So today we're going to try to divide some polynomials by other polynomials by using long division. So if we look at this first example here, it says divide by using long division. And so we have x squared minus 6x plus 8 divided by x minus 4. So long division from our review last time, we remember we should have this box here. And so we'll take this term over here, this x minus 4, let's put it on the outside. And then we'll take our other term, our x squared minus 6x plus 8, and put it on the inside. So when we do long division with polynomials, we'll be operating on this x right here and trying to make it go in, this x go into each of the terms under the division bar. So if we look at this first term here, we're trying to take x and put it into x squared. So how many times does x go into x squared? With our exponent rules, it will just be x times. And we know this because x to the first times x to the first is the same thing as x to the 1 plus 1, which is x squared. So when we multiply our x by x, we'll get x squared. So we'll go ahead and do that. We'll take x times x, which we just talked about was x squared, but now we'll also take this negative 4 times x, which is negative 4x, and this whole term is the term we're going to be subtracting from the first two terms of this polynomial. So we'll flip the signs on both of them. Our x squareds cancel out, and then we'll have negative 6x plus 4x, which is a negative 2x. And then just like last time, this 8 over here will drop down, and so we have negative 2x plus 8. Now we'll do the same thing. We'll take this x over here and say, how many times does x go into negative 2x? Well, that is negative 2 times. So x times negative 2 is negative 2x, and negative 4 times negative 2 is positive 8. So now we need to flip our signs. So negative 2x plus 2x, and instead of a minus 8, or sorry, a plus 8, it's a minus 8. So we have negative 2x plus 2x is 0, and positive 8 minus 8 is 0. And so now we're done. So we are that the quotient, or what it should be when we divide this polynomial by this other polynomial, this x minus 4, is x minus 2. And if you notice on this time, the example we did in the last video had a remainder, but here the remainder would just be 0, because down here, everything divided evenly. So what that means is that 4 is going to be 4 is a factor, this x minus 4 is a factor of the x squared minus 6x plus 8. So let's look at another example right here. So we're going to divide by using long division again. We have x squared minus 4x plus 7 divided by x plus 3. So we'll set up our division again. So x squared minus 4x plus 7 on the inside and x plus 3 on the outside. And we'll go through the same sort of process. So how many times does x go into x squared? Well, we discussed this in the last example, and we know that it's x times. So x times x is x squared. And 3 times x is a positive 3x. We flip our signs. So we have minus x squared, minus 3x. Our minus x squareds cancel out. Now we have minus 7x. We'll bring our 7 down. So we have plus 7. So then how many times does x go into minus 7x? Minus 7 times. So we have minus 7x. Then 3 times minus 7, or negative 7, is negative 21. We'll flip our sign, so we'll have plus 7x plus 21. Our 7x's cancel out. And here we have 21 plus 7, which is 28. Now, x can't go into 28 any more times because there's no x term, so this is going to be our remainder. So, just like we did last time in our example, we can take this 28 and write it as a remainder. So, if we were to have a number, we'd take the remainder number and put it over the number that we were dividing by. We can do the same with polynomials. So we had x minus 7, then we'll take our remainder 28 over the polynomial that we were dividing by. So x plus 3. So it's just like if you were to have that number out there. So if this is a remainder of 2 and this is a 3, we would write remainder 2/3. Here, since we have a 28, we'll just put it over the polynomial that we were dividing our other polynomial by, which is why we have 28 over x plus 3. And so since we have a remainder on this example, this means that x plus 3 is not a factor of x squared minus 4x plus 7. And something we saw in the last example was we had an 8 at the end, and here we had a 4. And so 4 divides evenly into 8, so we could have 8 over 4 is 2. But in this example, we had a 7 and a 3, and so 7 over 3, well, that's not going to be an even number, or it's not going to divide evenly. That's just, we could write it as 2 1/3. It's not a nice whole number. So 3 does not divide evenly into 7. So let's look at this last example here. We have x cubed minus 13x minus 12 divided by x minus 4. So we'll go ahead and set this up again. But if you notice, we could go from an x cubed term to an x to the first term. We skip our x squared term. Well, we're still going to need to use that in long division. So since there's no x squared term, we'll put a placeholder in. So the placeholder here, we'll just have plus 0x squared, because 0 times x squared is still 0. But it'll be important, and you'll see why in just a second. It's important to include that x squared. And then we'll put our x minus 4 on the outside. So we'll do the same sort of thing. So how many times does x go into x cubed? In this instance, it's x squared times, because x to the 1 times x squared is x to the 1 plus 2, which is x cubed. So we'll have x cubed. We'll take negative 4 times x squared to be negative 4x squared. Now we'll flip our signs. So our x cubes cancel, but now we have a 4x squared. So even though there's not an x squared term in this polynomial, we still have one when we do the long division. So that's why it's important to keep this placeholder term, this 0x squared. That's why it's important to include it. So next, we'll take x into 4x squared. In this instance, it goes in 4x times. So x times 4x is 4x squared. Oh, I forgot to bring the term down. So remember to bring your term down. I forgot to do it there. So now we'll take negative 4 times 4x, which will be negative 16x. We'll flip the signs. So we have a minus 4x and a plus 16x instead now. Our 4x's cancel out, and minus 13x plus 16x is 3x. This time I'm going to remember to bring the term down. So we'll bring this minus 12 down to be minus 12. And now, how many times does x go into 3x? It goes in, 3 times. So 3 times x is, let's see, 3x, and then minus 4 times 3 is minus 12. So we have, when we flip our signs, a minus 3x and a plus 12x. So 3x minus 3x is 0. Negative 12x plus 12x, sorry, negative 12 plus 12 is 0. So this doesn't have a remainder. So this is what our answer should be. But what if we're not convinced that this is our answer? What if we think we made some sort of mistake while doing long division? Well, we can always check our work by taking our answer. So we just had x squared plus 4x plus 3 and divide it by what we divided, or sorry, multiply it by what we divided our polynomial by. So x minus 4. So we could just use the double distributive property like we did a few days ago with our exponent rules. So we know this is the same as x times x squared plus 4x plus 3 plus negative 4 times x squared plus 4x plus 3. And now we can just use the distributive property. So x times x squared is x cubed. X times 4x is 4x squared, and x times 3 is 3x. Now we'll come up with our next expression. So negative 4 times x squared is minus 4x squared. Negative 4 times 4x is minus 16x, and negative 4 times 3 is minus 12. So let's get all of our like terms together. We only have 1x cubed. Here we have a 4x squared and a minus 4x squared. Here we have a 3x and a minus 16x. And then here we just have a 12. So this turns out to be, so we just have x cubed. We have plus 4x minus 4x, so that's plus 0x squared. We have plus 3x minus 16x is minus 13x, and then we're just left with our minus 12. So since we had that 0x squared, we could just rewrite this to be x cubed minus 13x minus 12, and this is our answer. And this was the polynomial that we started with in the last problem, x cubed minus 13x minus 12. So if you're ever not sure, you can use the distributive property to multiply everything back out and double check your answer. So that could be helpful, again, if you're not sure, or if you just want to double check that you got the right answer.